I will say, maybe just because I'm presenting it, is probably the most used and the most maybe misunderstood topics of cost estimating. In any cost estimate that you build, you will deal with inflation, risk, EVM, contract. Those kind of things are all very important, and not, I don't think necessarily not much more complicated to understand than inflation, because we all deal with inflation every day. We understand it, that costs continue to go up, but the way that we handle that in the cost estimating world is a little bit different. So if anybody's having any problems with the slides or the presentation at all, this is very informal. So please just raise your hand. Dr. Smart or Teresa, if you can let me know as I'm presenting this, if somebody's raising their hand and wanting to ask a question, then just stop me, and I will try to handle that question as much as I can. So we're going to be talking about inflation, and I'll start by saying that inflation in 2021, the DoD put out a new way to handle inflation. It's much more complicated than what we're dealing with now, than what I'm presenting now. But it hasn't really taken full effect, and I'll talk a little bit about that as we go on. So one thing about inflation is the terminology that we use, and I'll go over a little bit of that, and I'll talk about different indices that we use. But mostly this is going to be focused on how we apply inflation to our estimates. So the terms, we say context matters. I say context matters in the way that some people will refer to different terms depending on where they come from. The Army specifically uses different terminology than the Navy and the Air Force when they discussed the way that they handle the inflation and in particular the inflation indices. So weighted index, for math people, that's a term that they understand. It's the weighted average among kind of different things. So in the inflation world, weighted index can mean the use of an average versus multiple or using multiple commodities. It also can mean versus using weighted averages against outlay rates, and I'll explain outlay rates here in just a few minutes. But essentially, that's the way that the timeline that you spend the money on. Sometimes different terms can mean the same thing. The weighted index can say, or the weighted index and the composite index, we can use those terms. Some people will use those terms as the same, but when calculated, the weighted averages mean multiple appropriations, and I have the Navy definition of a composite index here, of saying that there's different appropriations, and we'll call that the weighted index. So for today's presentation, what I mean when I say weighted index is the weighted average using multiple outlay rates. For the composite index, it's the weighted average using multiple commodities or products or supplies that you use. Inflation and escalation, I believe this can be confusing as well, where we say inflation is just the general rise. Just, we all feel inflation. We know that we're spending a lot more money out of our pockets than we were, whatever, a year or a couple of years ago overall. But escalation is in particular for gas, for milk, for eggs, for kind of a particular product, a good service that we use. And I have underlined here, it can be positive or negative, because when we think about the general rise, so the inflation kind of rise, or even for a particular product in general, we think that it's always going to be more expensive. Well, fuel, for example, is a different kind of beast, where we know that it goes up and down and up and down. But escalation really, when I'll use that term, is in particular for a particular product. The price index accounts for change over time and compares current prices with previous. And the one that I always remember is movie tickets. Movie tickets back in, I don't know, 20 years ago were $1.50, and now they're $10 or something. So we would say, we would apply a price index to say this is the difference between today's prices and the way that they were, 20 years ago. They're 150% or 3.5 times the amount that they were before. So just a quick example on price index. If we have an item that was $105 in 2018, and we believe that the identical item can be purchased for 112 a year, then we would compare those two prices and try to figure out what the true difference in the amount that we're going to pay is. The inflation rate is noted here, just the difference between them divided by the original time. So we're saying that it costs 0.07 more this year, well, in 2019 than it did in the previous year. The price index is simply just 1 plus that. It's just the new cost divided by the old cost, and that would be what we call the price index. Again, inflation rate is the difference in the increase as opposed to the price index, which is the multiplicative number that we would use to compare the two prices. Composite index, as I described before, is that I'm going to use in this presentation is more of a commodities thing. And the easiest one is the consumer price index, which I think we hear often. And that's essentially a grocery cart full of different goods. And we say last year it cost this much, and this year it costs whatever, this much more. So the steps for computing that index is you determine how much of each individual product is, how much that particular product has increased in price, and then you add them all together, and that is the new consumer price index. Now, this is a very simple example where you could obviously just take two grocery carts, one last year and one this year, and just do the totals in the division. But in the case of different sort of items, you would want to do each individual product and say how much does it individually affect the total cost. And that's what we have here. So we say that this lawnmower frame cost consists of these three items: steel, plastic, and chemicals. And we have a different percentage of the total frame made up by each of these different kind of commodities. 80%, for example, for the steel, 15% of the frame is plastic, and 5% of it is cables. So the steel, we say, maybe per pound, it went up $75 to $76.50. So that in itself, the inflation rate for that would be 2%. Continuing down to the plastics, which is only 15% of the material, but it did go up 5%. The cables went up themselves 17%, but only make up really a small fraction of the total cost of the or the total makeup of the lawnmower frame. So I kind of have those numbers just split out sort of here in different outline forms. So that 80%, 15, and 5. We have the price indexes now. Remember that the inflation rate was essentially 1 minus this, 1.02, 1.05, and 1.17. And then we take the index for each particular commodity times the amount or the percentage that it applied to that lawnmower frame, and we sum that up and say, okay, it's about 32 or 0.32%. Sorry, 3.2% above what it cost in the previous year. So if it cost $1,000 in 2018, then we were expecting the following year that it would cost overall $1,032. And this is, I'll kind of introduce the new changes where the inflation rates that were given by OMB to use are overall, again, just overall inflation of everything all put together. Where these particular ones, the 1.02, the 1.05, and the 1.17, would be specific sort of commodity or industry numbers, And that's kind of where the difference is. I'm not going to get too deep into that again because it hasn't really been inculcated into the DoD cost estimating world. But in general, that's the change. If you ever see that discussion about specific price increases, that's what they're talking about. Instead of a normal 3% overall inflation rate, they're looking at these different numbers of the 1.02, 1.05, and 1.17. Some other definitions that you need to be aware of are the ones listed here. Current year dollars is dollars that you actually spend. So if I take a dollar out and spend it today, that is a current year 2024 dollar. When I alluded to the movie ticket example, we're trying to compare different years. So 20 years ago to now, well, we can't really use the same because the same number. If it was a dollar back 20 years ago and it's a dollar now, well, the dollars themselves are basically different. The buying power of those of that specific dollar is different. So when we're trying to compare actual prices between years, then we were trying to set them to a constant year. You can pick one. You can pick either the 20 year ago or now, or frankly, you can pick any year and be able to adjust both of the expenditures to a specific year, and then you compare and say, well, this is much more. I think of college tuitions. Well, normal inflation is say 3% every year. Well, so we expected 20 years ago that it would be 3% per year between then and now, and it would be whatever, I don't know, 50 or 70% increase. Well, clearly it's much more than that. So we would say, well, that's kind of an anomaly, that it's different than what we would expect for a normal inflation. Again, inflation, overall economy increase in the dollar, or the decrease in the ability to spend that dollar. Then your dollars are dollars adjusted for outlay rates. Again, I'll talk about those in a little bit, but that's assuming that I'm going to spend the dollar that I've been given over a number of years. Think of it, I make a dollar, I put it in savings, but I'm not really going to spend that dollar this year. I'm going to spend it over a number of years. So then your dollars are adjusted for those outlay profiles, and we're essentially given those. Now, when we use those then your dollars, we use those for budget estimates or for POM budget requests, and that's what generally you'll report your cost estimates in when you're providing them to try and get those dollars from Congress if you're in the government, specifically military world. Remember when you talk about these that especially for the current year and constant year dollars, you have to specify what year you're talking about, because again, the inflation rate will affect how you look at those specific dollar amounts. If I'm looking at if I'm going to compare the 20 year ago to now, I need to say, well, am I talking about the 20 year ago time frame, or am I talking about the now time frame or the 2024 time frame when I'm talking about this is what a dollar would buy. So base year estimates are good for comparison. In the previous slides, I talked about current year and constant year. Those are base year. So those don't include anything about the outlay rates. Those are really good for comparisons. Like I said about the movie or the movie ticket prices. Those are really good for those kind of comparisons where I can say, before I expected it to be this much. Now I'm doing a new estimate, and it's this. It's a different amount, probably higher amount, but I'm not including sort of the outlay rates or the then year dollar calculations that we'll talk about a little bit later into those. So the program office estimates or the livestock estimates, the APBs, where we do at generally the beginning of a program, and we compare how much we're spending now versus how much we expected to spend when we first did them. Those are very good because they don't include the different inflation indices that we brought in based on the new POMs or the new guidance that we were given. Then your estimates are planning. Again, I try to kind of foot stomp on this. Is those are only for the planning and only for budget purposes, for budget submissions and for trying to get your POM requests in.
Don, I've got an age-old cost estimating question for you. So, the 1921 cost reports are our bread and butter. Let's say that we've got a final 1921 for a 5-year contract that started in 2019 and just now ended in 2024. So we've got a midpoint of the effort, and let's say that the midpoint is 2022. Is that midpoint, and are those dollars constant year dollars, or are they then year dollars?
Well, if there are actual expenditures, the money that we actually wrote the check for, then they would be expenditures. So they would be constant year dollars, or there would be, depending on how the report is prepared, they would be either constant or current year dollars. Because the contractor doesn't tell us, doesn't give us a bill and tell us which budget year we had to pay it out of. Right? They just
Correct.
say they just say, give me the money. So I would say, and this is the argument I've had really since I started, but it's, if you get an actual and you're using that in your estimate, you should enter that as a constant year dollar, or a current year dollar. If you say, I have this report and it says that we gave contractor X $100 that year in 2021. I would enter that into my cost estimate and say that's a 2021 $100, and that is a constant year dollar. I've seen many organizations, not many. I've seen some organizations that say that will enter that as a then year dollar, saying, well, it was obligated, but I have no idea if it was obligated, specifically something like RDT&E. I don't know if it was a $2021 or a $2020 that was obligated or that was given to us by Congress. I really don't know, but I know for sure that we paid the bill in 2021.
And so that's exactly how much we paid. Yep.
That's exactly how much we paid.
In all of my years of asking that question, and it's debated every time, I don't think I've ever heard as good of an explanation as the one that you just gave. I like it, and you just convinced me that that those are constant year dollars. Thanks, buddy.
Now, if you get the contract numbers, if they just say, hey, this was the contract, and you're using that, well, then I would say that then you're probably is best, because the contract is really obligated dollars, right? When we sign a contract, we're going to go say it's $100 that we're going to pay you this year, but the contractor may charge us that year, or they may charge us 2 year, next year, or 2 years, or 3 years down the line. Again, all that's provided by OMB, which is a kind of a chart that I'll show you here in a little bit. But that's I think the difference. If you get an actual expenditure from the CSDRs or those, then I would suggest that that's a then you're done. Now, Dr. Smart, you can certainly counter that, but that's my understanding of the way that things are done. So when we talk about the constant year or base year, constant year, current year dollars, then we're talking about the raw indices, and that's what we'll use to convert from, say, 2018 to 2024. If I get, as we just discussed, we have a 2021 $100. Well, I heard somebody that paid for this product, say the lawnmower, they paid $1,000 back in 2018. How much do I think that I would do that how much would I spend on that today? Well, you would use a raw index to do that. If I said, okay, well, government's going to give me money or I'm going to request money, then I'm going to try and use the then year dollar because that's going to be the obligation. And we'll talk about that here in a second. But that's the real difference between the raw and the weighted indices. Raw indices go from sort of actual dollars to different year actual dollars, where the weighted indices will go from then year dollars to other than year dollars. If we have to obviously convert from a base year dollar to a then year dollar, then we'll have to use both, where we convert one to the base year of our table to the then year for the budget request. So as I talked about the acronym before a couple of times on OMB. So OMB in the president's budget, they will give us guidance, and that's all of the government, especially the DoD, to say you have to all use these same numbers to calculate your inflation, and that's essentially just to put us all on the same field, a level field. To say, the Air Force can't use, oh well, it's going to be 10% and the Army uses 1%. Well, obviously the Air Force then would be requesting or saying that they need a lot more money than the Army would for the same sort of product. So the way that flows, OMB will provide it to the DoD, again through the POM guidance that we're given, the program objective memorandum, which is essentially the president flows down. Hey, this is what you're all going to use. The OMB pushes it out to the DoD, which further on pushes it out to these other agencies that I have listed here to say, this is the guidance you're going to use. Everybody has to use the same thing. And again, just to put us on a level playing field so that we're all essentially asking for the same thing. It comes in a memorandum that's shown here, and I know that the typing is real small, but what I want to try to highlight on this page is there's a couple different parts of it. The middle page is the price escalation indices. So that's from every year to the next year. That's how much you should assume that the prices are going to go up. And it's always in the future. Obviously, in the past, we should kind of know that information, but we're estimating into the future. And so that's the information that it will give us. The third page, or the page that's furthest on the right there, is called the outlay rates. And I brought that up before, but I'll discuss that a little bit more on why that's important and how we use that specifically on then year or budget dollars, budget cost estimates. This is just a blow up of that middle page. Again, it's the price escalation indices, and these are just annual rates in percentages. So just think of, say, 2014 is 1.5% greater than the previous year. And you generally won't see these. You'll have people like Paul Gardner or somebody else in your organization that will take these indices and build a table. And I'll talk about how the tables are built and then how you use the tables here in just a minute. But that's what they will provide us. And you'll see that they have different, not only just appropriations, but even sub-appropriations. You have procurement, RDT&E, Milcon, O&M, and it has the big exclusion there. And kind of what I talked about before with fuel, you'll see that in general, inflation will always be a positive number. You're always going to spend more next year than you did this year. And fuel is sort of the oddity in that it sometimes has, as you see here on this chart, it sometimes has a negative. Why they expect fuel prices in 2016 to go down 7.3%, I don't know, but that's what they're telling us that we have to use. So we don't have to make the decisions. We just have to use the information that we're provided. So this is calculating future raw indices, but I probably should add an extra slide in here to say this is how you would calculate if you just had a number, say the cost of a movie ticket in 2016, and you said, well, okay, well, how much is it going to cost me in 2019? You would have to take those each each of those individual indices, and I have those listed here under the fiscal year and procurement columns on the slide here. So again, each one of these columns, so the 2014, the 1.5 that's listed there is from 2013 to 2014, it's about a 1.5% increase. And then from 2015 to 2016, from 2014 to 2015 would be a 1.4. So you would have to, every single thing in your cost estimate, you would have to individually multiply by each one of these escalation percentages to get. Well, instead of doing the products of all those for every single line, we build what's called an inflation table. And that essentially just does all the work for you so that you just have to plug your dollar amount in 1 year to get it to the year that you're looking for. So in this example, we're going again from 2000. We have a base year 2016 table, and we're trying to figure out the 2019 inflation factor for that table for that year. So we would take the product from 2017, 18, and 19, multiply those together, and we would call that the RI is the raw index for 2019 in the table. And I'm going to switch over here. Just let me move this to, because I realize it's. So this is what a table would look like. And can you see the table now, all the numbers? I don't know if it's big enough. Let me try and make it a little bit bigger. So in this case, the table is a 2022 table. It's a 2022 table. So obviously, if I'm going to go from 2022 to 2022, it would just be 1, right? I mean, there's no inflation, and this is the raw stuff. Okay, so all the raws would be 1. Okay, you see here, here, and here. And now, instead of having to multiply a particular line or a particular item by each one of those numbers that was listed in here, I just have to multiply it by one number. I just have to multiply it by whatever is listed here. So if in this example, if I wanted to go from 2016, or rather from 2022 to 2027, I would just multiply it by 1.18 instead of having to do all this work for every single thing that I'm doing. So that's why we build the tables. And again, those are generally built for you. You would very rarely have to use, as a cost estimator, to use these individual escalation rates. You would just go to this table and take, I'm going from one number to another number, right? But to build the tables, and I think it's important, almost in a theoretical sense of how these things are built. So you would, again, from going from 2016, because I said from 16 to 17, that's the number here is 2016 to 17, 17 to 18, 18 to 19. So those are numbers I would use. That's listed here. And then I would say, okay, my raw index for 2019 from 2016 to 2019 is this number here, 1.058. If you ever have a question, like I showed you on that Excel sheet, that if you're looking at a table and you're not sure what the base year of the table is, it's always going to be 1 for the raw indices. Okay. So just kind of almost a textual example of what I just said is you take it by the year that you're starting in. If you're going into the future, so it's a 2016 table, I'm going to 2019, I would go the 2017 factor, 2018 factor, and 2019 factor, and then I would continue until I was to the appropriate year that I was at. Okay. If you're going into the past, it's basically an inverted formula or equation for this, and you just take the base year of the table and subtract one, and then keep going backwards until you get to the proper year. Again, this is something that you won't necessarily have to manually do, but I think it's important that you understand how to do it, or how it's done. So this is just a numerical example of the numbers that we had before. So now we get to 1.0589 and then 10729 for the 16 to 19, and then backwards. Oops, let me get back there. And then again, this is the table. So these are the different Rye indices that we're going to use. So 16 is 1 because that's the base year of the table. Then we get to the 1.018, which is here, 1.0374, 1.059, and then 1.079. So the weighted indices, as I brought up before about the outlay rate. So when we're asking for money, when we go back to let's see if I've got this. Okay, so when they give us the guidance, they say, okay, Army, Air Force, NDA, whoever, we expect when we give you $1 in 2024 that you're going to spend 6.3% of that in the first year, 27% in the second year, because they are multi-year appropriations, right? And the third year for procurement, because it's 5 years, you'll see that even in the fifth year it says 8%, but it's got stuff beyond that, and that I attribute to the contractor can always come back to us and ask for money that they've forgot or made a mistake on asking us for before. And you see that those numbers are obviously very small compared to the totals. You're looking at maybe 4 or 5% here, but RDT&E 2-year money that is obligated in this year, but can be expended in following years. All right. Milcon, again, the same thing. So the funds aren't always changing hands in the year that they are appropriated. So each portion of the dollar that we're given is affected by inflation for each one of those years that it's actually expended. And the DoD memo will give us those specific outlay rates. Again, not a decision we have to make. We just follow the rules and say, okay, well, this is what they tell us we have to use so that we can all play on the same playing field, on the level playing field. So it allows us to change a multi-year bill or a multi-year contract and be able to expend, or multi-year really appropriation, and say we're going to spend that over a number of years, either based on we're not going to actually sign the contract for a year, or after we sign the contract, they're going to keep coming back to us for money. So to create this caution here is really for an exam, but really it's for you to just think about is you have to have an outlay profile to create weighted indices. In the raw indices, it was just 1 year to 1 year. It's $1 that I actually gave to somebody in 1 year versus $1 I gave to somebody. Well, now when we're talking about money that's given to us from Congress that we're going to expend eventually, then we have to know how much that they expect us, or they're going to tell us that they expect us to spend. Showed this slide a little bit, and again, these are all given by the year of the expenditure. This one happens to be in 2014, but it's also given by different procurement. In this case, it's not just procurement, but it's Air Force procurement and defense-wide MDA kind of things, and then RDT&E, various things down here. O&M generally is a 1 year, and it appears that OSD now says that it all has to be obligated and expended in that year. That's kind of the way that they're treating it in their new guidance. Although I've seen a little bit different things in the past where they do say 1 year, 98%, and then the following years, the rest of it, again, because the contractor may come back to us and ask for more money. Very challenging to try and figure out the differences, especially with the way that it's calculated by the Army Navy uses the same one, but then the Air Force Navy uses the same one, and the Army uses a different one. Because the Air Force Navy one is so complicated, I will just talk about the Army Composite Index. Again, composite index of using different now appropriations of different years for a single index. But as you notice here, that they all use that raw index that we talked about before. So we calculate that one first, and then we use how much we expect to expend. In the previous slide, talked about whatever 78% or something in the first year, and so we use the raw index for that first year, 25% or 20% in the second year, and then multiply that by the raw index of that year. This one is much simpler, and again, it's just a weighted index. So I'm sorry, I'm going to use the Air Force Navy one. It's more complicated, but the Army is so much easier that it's just if you look at this equation, it's just that much simpler to calculate. The numbers are different, frankly, but it's just the way that they're able to convince the DoD that they're going to provide the information in this way. So first of all, you get the outlay rate, which was provided in the previous slide there that says, in this example, we say it's the procurement, and it's 2022, 25, 20.8, and all those specific years of the outlay rate. Change that to a factor, and then we calculate, second step is to calculate the raw indices, which we should have already done or have already been provided. And those are the numbers that I showed you earlier when we calculated those raw indices for a 2016 inflation table. The next one is to divide the outlay profiles by the raw indices, and you can see those numbers up on the top, the same numbers that were on the previous slide, just divided by each other. So you can see the 0.22 there in 2016 in 2016 rather, and then we sum all those together for the particular appropriation, in this case procurement. It's listed all out there. One other thing is just make sure that your outlay rate, the outlays are always adding up to 100%. Obviously, we're expecting to expend every single dollar that we're given. So then we get the 97.9765 or 97.65%. So the $1 program would actually only cost $97 because we've given the money in advance. If we could pay for it all in 2016, we would only spend this 97 or whatever for a $100 program. We would only expect to spend 97.65 if we could actually hand the money over to the contractor and say, here's all the money you're going to get for this program. And because of inflation, it'll end up equaling the $100 as we go out, but we only have to spend the $97.65. Unfortunately, that's not generally the way it's done. So really what happens is we have to ask for the inverse of that, or 1.02% from Congress, so that we can spend part of it in 2016, 17, 18, 19, 20, all the way through 2022. So we would have to ask for or in this case, $102.40 to pay that eventual total $100 bill. So to create the table means you have to do that all those steps that I previously showed for every year, which of course is not easy at all. Again, if you're just doing it individually. So what we do is just created the weighted index, and that was in that other table. And I'll show that back up here. So this is all Army stuff, but it's for APA. You see that the 1.0 now, if I was going to spend it this year, I would just have to request $1. But because APA is expended over a number of years, I have to ask for more, because they're going to ask for whatever 5 cents or something next year. But that, because of the inflation, it's going to be more than that. So that's why you'll see that all these numbers are different. Again, things like military pay, they expect to have it all expended in the same year. That'll be one. For OMA, they again, all that is expensive. Does everybody understand the OMA, APA? If anybody has a question about that, fire that up and either put it into the comments, the chat, or just let me know following. So to use the indices overall, just always think there's a number of different slides and other ways that I've seen to try and determine this, but just always think to over from. To over from, that will get you to the correct application of inflation every single time. So the first one, base year of X, if I have $100 of base year of X and I want to change it to year Y, then I say to over from, and you just have to remember that if it's a current or constant year dollar, I use the raw index. If I'm going from or to a then year dollar, then I use the weighted index. So in this example, simply it's the $100 of base year XX dollars I have times the 2, which is the YY divided by XX. And that is true for every inflation calculation or application that you will have. It's always to over from. To over from, that's it. Don't remember anything else. That's just what you need. And this is following is just a number of examples. So we're going from base year 2009 to 2012. So I start with my $2009, say it's $1,000, and I'm going to go to, which is my 2012 raw index, because we're talking about base year again, divided by my 2009 raw index, because I'm looking for a base year $2009. Okay. I'm sorry. So yeah, to 2012 and divide. I'm coming from a $2009. So $1,000 in 2009, I would expect it to cost me $1,046. Kind of a shortcut here is just in general, except for fuel, and maybe some odds and other things. If I'm going to the future, it's always going to be more. If I'm going to the past, it's always going to be less. And so if you're doing your calculations and you notice that that's not right, then probably the numbers got mixed up. So in this case, we use the raw index of 9.573 for 2012 and divide that by where I'm coming from, which is the 9146. All right. If I'm going to a then year, then obviously I use the weighted index of 9520, but I still start with the 9146 because that's my source data is a raw number. It's an actual dollar that I've spent, current or constant year. Anything here except for I'm going from a then year dollar, so I'm going to divide by the weighted index of 2009, and I'm going to multiply by the base year index because I want a base year number or current constant year number. The bottom block is then year to then year, so weighted index over weighted index. Another thing, kind of a shortcut or a way to do a quick check is that the weighted index will always be higher than the raw index for it. So if I change a number from a $2009 $1,000 to a raw index and it happens to be let's see 1046, then I would expect the numbers to be higher if I was going from a raw base year dollar to a then year dollar in the future. So that's the inflation kind of discussion. And again, I'd be happy to either now on chat or in the future at any time. For those of you that have been on the emails, or Teresa, if you have all their emails, if they're interested to get the emails, I'm the guy that sends out all the emails for ICEAA North Alabama. And so feel free to contact me at any time, and I'll be happy to answer the questions as best I can, or generally hand them off to either Paul or Dr. Smart. So now we're talking about nominal and real rate of return. so you can see the question here, invest $1,000, how much is it going to be worth in 6 years? I think most of us understand that there's going to be a difference depending on the way that the interest rate is applied to it. So the nominal rate is a general rate of is sort of a savings account rate that I'm just going to get this much over this amount of time, whatever 5-6%. Well, I guess in savings accounts more like 0.5 or 0.6%. Simple interest is just whatever your present value is, and you multiply that times the interest rate. And that depends on the number of times. So if I have $1,000 and I get 3%, then it would be 3% times or whatever 100 or $1,000 and 30, and then I'm going to get $30 the next year and the next year and the next year. For compound interest, it's I'm going to take the present value, the value that I invest in, and the first year I'm going to get 3%, but the next year on the $1,000. But the next year I'm going to get 3% on the $1,000 plus the additional money I had that I gained from the first year. So that would be the compound interest. And you'll see the difference in the calculations where it's just multiplied by n, or the number of time periods, versus 1 plus the whatever interest rate to the as n now as an exponent instead of just a multiplier. So in this case, compound interest, it's using 5%. I'm just going to use this number 1.05 with an exponent of 1.6, and I'm going to have this. But because of inflation, I understand that I'm not really going to, well, although I have that in the bank, it's not going to have the buying power that $1,340 would have this year. So in 6 years, $1,340 isn't going to be worth essentially as much. It doesn't have as much buying power as $1,340 would be in 6 years from now. So the real rate of return then is calculated with the 1 plus the rate. In the last example, it's 5%, divided by 1 plus the inflation rate. So you need to kind of not really subtract, but essentially account for the inflation rate, and then you subtract 1 from that, and then you'll get your number here that's shown below is 2.63. So instead of 5%, I'm really only getting a 2.7% return on the buying power of the dollar that I invested this year versus from 6 years from now. So in our case here, the $1,000 that I invested 6 years from now is not worth the previous number, but it's only worth an extra $169. So that last part you won't really have to deal with, the real rate of return in investments. And it's not just for investments, but obviously it's for costs that you may have to pay. But that's more of a ICEAA exam kind of discussion. It's something that you should be interested in. Frankly, I'm more interested in that discussion from a personal standpoint than I am from the professional standpoint, because the government doesn't really concern themselves so much about the real rate of return because they're not investing money. They're trying to buy something now and looking forward to how much is it going to cost me in the future. So the big things are know what you're talking about, know what the other person that you're talking to is talking about, so that be clear on what that you're talking about, that you're speaking of in the same terms as each other. Escalation, inflation, different kind of terms. Just make sure you know what you're talking about. The weighted average, when they say that, a composite index or a weighted index, tell me exactly what you're talking about for those things. The big one right here in the middle, to, over, from. If I have a cost that I'm given as a source, for example, then but I want to apply that to my estimate either now or in the future. Make sure you just always think of to, over, from. The correct inflation table, as I talked about, if you see a line in an inflation table that's pretty much all ones, especially the raw indices are all ones, well, that is the inflation. That is the base year of the inflation table. But you can use a base year of you can use an inflation table no matter what base year it is to escalate from any year to any other year, regardless of the base year of the inflation table, because you're always going to do the to over from. And again, just make sure you're using the correct appropriation and service for whatever particular duty you have. Raw indices are used only for current and base years. Transitioning those, generally you'll transition those to the base year of the inflation table, and then you'll use the weighted years, the weighted indices for then year. And remember, then year is obligations. It's what I call pretend money. It's what we hope to get and then what we expect to spend, but it's not actual dollar being transferred from our hands to the contractor's hands. So some cross checks, and I talked about these during the presentation. Just always, again, except for fuel, always expect that if I'm going from now into the future, or from any time in the past to any time in the future, it's always going to be higher. So if you're doing calculations and it's not like that, then you have to look at your calculations. All right. Weighted indices are always higher than raw indices, again, except for the fuel issue, and that one you just kind of have to keep track of. I've run into that problem a couple of times where I was confounded as to why it was less, but you go back and you look at the fuel, and that's kind of the biggest player in that. Weighted averages, when we're doing like the commodities, the lawnmower example, if you go back to the slide, you'll see that the weighted average will always lie between the lowest index, or the lowest number that you've calculated, and the highest index. So that's another just cross check that I will use to just kind of say, does it make sense? The Army method for weighted indices is about equal to the Air Force Navy one. Again, as I showed, the Air Force Navy one is extremely complicated, as opposed to just the weighted average, essentially, that the Army uses. But it's a good approximation. You'll be forced by whatever agency you work for to use either the Air Force, Navy, or the Army method. But specifically on the exam, they'll ask you for a weighted index to calculate a weighted index. Number one, remember that you have to have the outlay rates, and number two is the Army. You can quickly do an Army method and knock that question out, and you'll be pretty close. The nominal rate of return minus the inflation rate, and that is approximate. So the 5%, I think I had 5% rate of return and like a 2% inflation rate. That's 3%. That's going to be pretty close to the real rate of return. Again, if you do your calculations that's somewhat off from that, then you need to kind of question your calculations, or at least go back and look through them and make sure that you applied all the calculations correctly. So before we get into sample questions, are there any questions from the audience? Do we have any chats or questions raised? Not yet. Okay. So these are just going to be some questions and then some examples of what we discussed before. So money prices expected terms actually observed are what kind of dollars? In this case, it's going to be current year dollars. Okay, dollars reflect, I think there's an answer key that's beyond these. Dollars reflected against a specific year that have been adjusted for inflation. Okay, that would be the constant year dollars, because we're just comparing everything by itself. It's going to be a $2024, and we're comparing movie ticket prices to 2024. Dollars have been adjusted for inflation to account for outlay profiles. If you ever see outlay profiles, you know that has to be a then year dollar, because that's just the pretend money that we're asking for this year to be able to spend over the subsequent years. Budget estimates, again, that's our POM requests, our budget requests. They're going to be in then year dollars, escalating from a certain fiscal year in constant dollars to another fiscal year in constant dollars. Hopefully you all recognize that to be raw indices. constant or current year dollars always. It's only the budget dollars that we're talking about that will be in the year. From an FY and then year dollars to another FY and then year dollars, we're just going to use the weighted indices. So the key part of this question is the general change in prices. And again, that's going to be the question, general inflation rate. Well, I'm stumped on this one. Anybody got an answer? Going on in a few slides. So general inflation should be the raw inflation index. General, although it could be composite, so I'll have to go back and check my work on this one. Inflation index that captures different amounts for different multiple commodities is going to be the composite inflation index. Again, composite in terms of this presentation, when I'm talking about composite, it's going to be the multiple commodities versus the multiple outlay rates. Index that combines raw inflation indices and outlay profiles. Again, that's going to be the weighted index, because weighted index, outlay rates, budget estimates, those are all going to be the same. So these are more the calculation things that I'll let you go through. Hopefully everybody who's gotten the slides from Teresa, they can calculate these. And if you got any questions on the way that these were done, then again, just please let me know. And I'll just go through these real quick for the solutions. And I tried to put them down fairly simply to be able to explain. But with the escalation values, this is how you would build the indices for all those. So escalation rates are what we're given in the OMB guidance. And what I would say is when I'm going from one number to another, when I don't say inflate, I say escalate, but that's me. I don't know what the proper necessarily term is. Has anybody tried any of these examples? If not, that's okay. If you go through them later and you have any questions on how they were done, or certainly if you see any errors, then obviously I want to know that so I can make sure I'm presenting good information to you. All right, I know it's kind of quick. It's a lot of information, and a lot of it is stuff that you won't necessarily have to do your calculations on, specifically on how to build a table. But I think it's important that you understand kind of the kind of theory behind it, so that you can, when you use them and explain them to your decision makers, that you can say, this is why what you gave me is different than what I'm providing you back. So if there's no questions, Dr. Smart or anybody else.
Okay, thanks, Don. So we're going to, this is recorded, so this will be posted on the chapter YouTube channel. You can view it later. If you look for Greater Alabama ICEAA chapter on YouTube, you can find it. It should send out the link. But this will be posted. The previous trainings, except for the introduction training, those trainings are also been recorded, and they're on the chapter YouTube channel. Thanks again, Don, for doing this training. It's really good information. These are, some of the calculations that he showed towards the end of the exact kind of things you need to know if you're going to take the exam. Doing some of the nuts and bolts, as well as some of the conceptual. And next week we're going to have earned value management, earned value management, same bat time, same bat channel, and then 2 weeks from today we'll close out our chapter training with economics and statistics with David Byron. Okay, thanks, everyone.
Yep. So one last comment again, just if you're not getting my emails on a monthly basis for ICEAA meetings, then please let me know and try and participate as much as you can. If you're, especially if you're a contractor employee, I think it's incredibly valuable to be involved in ICEAA and it's even more valuable to be certified by ICEAA, because that lets any potential employer know that, and from a overall contractor perspective, to be able to say, we've got an ICEAA qualified person that's ready to take this job. So I think it makes you much more marketable, as well as obviously making you much more competent at the job you're doing.
Okay. I'll say one last thing. I put in the chat a link to the chapter YouTube channel if you're interested in seeing the recorded trainings. Okay, with that, we'll close it out. Thanks again, Don. Appreciate it.
All right. Thank you, everybody.